Okay, so we learned about triangles in 5.2. And now I want to do a few problems for parallelograms and for trapezoids. So let's look at the parallelogram example over here. The formula that they're going to give us for a parallelogram is base times height. And I pointed this out about triangles. Seeing it on the graph is helpful because you see what you're really finding and why it works. So this is scary when you hear, oh, it's base times height. Well, how can I know that it's going to be even when I do the base and go straight up? It's going to get some of that white right there, isn't it? You know, how am I going to find the actual area? Well, the nice thing is, if you think about that base, that really even base right there, going straight up, it'll get you some of this white area right here, but it'll also cut off the same amount right there. So it's kind of interesting how parallelograms work, because we know that these are parallel, so they're cutting off the same amount there and there. And anyway, parallelograms, it works out to just do base times height. But I just wanted to show you that on the graph, if that even makes sense. Because with formulas, it's good to know the formula, but then, you know, if you just are looking at the problem and you're looking at what you're doing and you forget how the formula goes exactly, although this one's pretty simple, then you can just know what you want to get, what you're doing. So anyway, you have to find the height is not this side. You know, when we had our rectangles and our squares, it was really easy. We would go, you know, a square, you would get the base, or it's called a side for a square. Or that's how their formula goes. It's side squared, because it's side times side. And the other side was always perpendicular, because that's how squares go, and that's how rectangles go as well. It's that perpendicular line that finds your height. Well, with, you know, and you would have a length and a width, which is really a base and a height. You know, but that's what we call them for rectangles. We're calling it the length and the width. For the parallelogram, you can't just use that side. So you've got to find the perpendicular, meaning it forms a right angle, the perpendicular line that goes to the highest vertex, and that's the height. Okay, so anyway, let's just do a few of those problems over here in the practice section. Let's start with number 1. Okay, we've got HM. I don't even know what that stands for our units. They've told us about HM over here on page 176. HM is a hectometer. Good to know. Okay, so we've got a base of 21 times a height of 13. So it will go up like this. It will technically add on more than we need here, but it will cut off the exact same amount here, so it will get us what we need without having to do any dividings by, etc., like we had to do with these guys. Okay, base times height. Okay, let's write this out. Area equals base times height. Okay, so I'm not going to draw it, but our base is 21 and our height is 13, so that's going to be a nice kind of a more complicated problem for us. We can't just do that one in our head, or I can't. I don't know what 21 times 13 is. Okay, so I'm going to do that out here to the side. 21, 13. 3 times 1 is 3. 3 times 2 is 6. 1, 2. Add them. 3, 7, 2. Okay, so the area of that parallelogram, because that one we know was a parallelogram because they marked it as such. These were the same length. These were the same length. So that told us. So we knew what formula to use for that. So that's 273 hectometers squared, or you can write it square hectometers. Either way you want to do it. Okay. Let's find another parallelogram. Look down. Here's one at 8. At 5. Okay, so it's area equals base times height. So over here at 5, area equals base times height. When you write them beside each other, it's naturally, it means times. So the base was 50, and the height was 8. Complete that little equation a step down and do the math. 50 times 8, well 5 times 8 is 40. And then an extra 0, so 400. But if you want to just be sure, just do it out to the side. 8 times 0 is 0. 8 times 5 is 40. So your units, what were our units for 5? It was meters. 400 meters squared is the area. We will do one more. I'm going to do one over here. Let's see. We'll do this one. It's a little more complicated. So number 10. Because we have to go ahead and count up our units because they don't, see over here they were just equal to 1, so you just had to count up 1. But this one we'll have to do a little more work, so let's try it. So there's 1, 2, 3, 4, but each of them's worth 3. So really it's 4 times 3. So it's 12. 3, 6, 9, 12 high. Height equals 12. Notice I'm drawing the perpendicular line up, and it can be drawn here too. Either one draws to the highest point in making a perpendicular line. Okay, the base, 1, 2, 3, 4, 5. So it's 3 units each. So 3 times 5, so it's 15 for the base. Base equals 15. Okay, so now we'll just do the math because this is a parallelogram, and I guess the way we would know it was a parallelogram because it's not marked, oh, you know, they're equal on either side, but we can see that the heights are equal and the sides are equal. I'm really not sure how, I guess 1, 2, 3, 4, 5, like whether it was a really close trapezoid or not. I just kind of know they're only giving you parallelograms right now. I just think they'll make it very obvious when they give you a trapezoid. So I was just assuming parallelogram, but there's probably a way to know that, and I'm just not so certain that I'm explaining that to you. Anyway, don't worry about that. So parallelogram, base times height. Base, area equals base times height. Area equals, the base is 15. And the height is 12. Okay, I'm going to have to do that over here. 2 times 5 is 10. 2 times 1 is 2 plus 1 is 3. 1 times 5 is 5. 1 times 1 is 1. Okay. Add it all together. 8, 1. So 180. Let's get that to focus. So area equals 180, what were our units? They were just units. Units squared. Okay, so there's your answer for the 3 parallelograms we did. Okay, now let's talk about